Hello and welcome to Math 143 Online. We're going to get started with Section 2.1, Systems of Two Equations. So we're specifically going to be considering systems of two linear equations, so we'll always be looking at lines, but you could extend this idea to systems of curves instead of just linear equations. To solve a system of equations means that we want to find the values of all the variables in the equation such that all of those equations in the system are going to be true. So what this means is if we have a system of equations that is, say, 2x plus 3y equals 7 and negative x plus y equals negative 10, we would be looking for a value for x and a value for y that would make both of these equations true at the same time. The first method that we're going to consider is substitution. This method is helpful when we have an equation that has at least one variable with a coefficient of 1. What we'll do is we'll solve for the variable that has the coefficient of 1, substitute this into the other equation to solve for the second variable, and then work backwards with the first to solve for the first variable. So let's look at the example that we have right here. We want to solve the system and check our solution. Now, we know that substitution is a possible method that we can use here because our x has a coefficient of 1. If there's more than one variable that has a coefficient of 1, then you can pick either one to solve for. But since we only have one variable here, we're going to go ahead and solve for x first. So beginning with the first equation, x plus 2y equals 7, we're going to solve for x. So x would then equal 7 minus 2y. So now that we've solved for x, we can go ahead and use this in the second equation. So we're going to substitute 7 minus 2y in for x in the second equation. So now the second equation becomes 2 times 7 minus 2y minus 6y equals 5. So we've substituted 7 minus 2y for x in the second equation. So let's see, if we distribute the 2, we'll end up with 14 minus 4y equal, 14 minus 4y minus 6y equals 5. And so let's combine like terms. So we have 14 minus 10y equals 5. And so if we subtract 14 from the other side, we end up with negative 10y equals negative 9. 5 minus 14 would be negative 9. And so finally we can solve for y, and y equals negative 9 over negative 10, which simplifies to be 9 over 10. So now we're at the point where we have solved for the second variable. We isolated the first variable, right? We isolated the variable with coefficient 1. We used that to solve for our second variable, so we have a solution for y. And now we're going to use this solution to go back into our equation for x. So we're going to go one more step, and now, just like we substituted 7 minus 2y for x, we can now say that x has to equal 7 minus 2 times the actual value of y, which is 9 over 10. So we're using our solution for y in our equation for x. So let's see, this gives us x equals 7 minus 9 over 5. And that simplifies to x equals 26/5. So we have a solution now. We have solved for both of the variables in the system of equations. And now we can go ahead and state our solution. So our solution is the point. We can write this as a coordinate pair. The x comes first, so the input value is 26 over 5, and the y would be second, so the output value is 9 over 10. So solution to our equation would be the point 26 over 5, 9 over 10. Now to check our work, what we need to do is evaluate both of these equations at this point. So if we want to check our work, we're going to evaluate the first equation at 26 over 5 and 9 over 10. and then we'd evaluate the second equation, and both of those equations should hold to be true. So I leave that for you to try on your own.